Hello, good evening students. Once again I am coming to model number 4, distribution system, under again reliability concept. So today it is well understood to increase the reliability of power system or dreaming of market structure, interconnections are more required in the nations, region to region, region to border nations. These are all required, or in inter region also. More number of transmission and distribution lines are essential, because to transfer the power, transmission line is basic need. If I sell the power, if I purchase the power, what is the route? Getting the idea? Hence there is a need of increase in interconnection system. Then we have to go for reliability of power system to the distribution of consumers. So this is the concept, transmission reliability criteria. In general, in the global level, N1 criterion is used in transmission planning. This is called single contingency. As a national approach, as concerned to nation India, N2 criteria may be adopted for large generating complexes that may be 3000 megawatt or more than 3000 megawatt, and also multi-line corridor systems, or any congestion in the transmission line. It is also referred as energy not supplied, ENS, megawatt hour per year. So as per research, this value may be given by sigma ENS equal to sigma 8760 into Li into Pi. This is the discussion under the global level. As coming to the nation, in Indian system, CEA finalizes this reliability criteria. Hence, as per CEA reliability planning criteria, the CEA uses the following reliability criteria on deterministic basis, but actually probabilistic criteria are more desired for better realistic applications. Under this one, we have to discuss number 1, lines. So as per CEA, the loading under normal operating conditions for lines 400 kV S bar C line, that is having the capacity 360 to 800 megawatts, 220 kV S bar C line 160 to 200 megawatt, 132 kV S bar C line 50 to 70 megawatt. After lines, next I move to generation. For transmission system configurations, hence that is in transmission planning, studies are carried out depending upon the generation scenarios, which is already worked by the CA. The peaking capacities and energy generation capabilities of power plants would be determined on the basis of following. So under this one, again case 1 or A, for thermal and nuclear power plants, the norms for deciding overall peaking capacity is depends, that is given by rated capacity minus maintenance at 5% plus partial outage rate at 15% plus forced outage rate at 17%, first plus auxiliary consumption at 10% plus spinning reserve at 5%. These are standard values which has to follow to get the better reliability. And it is one highlight, it is not realistic method. Total reserved margin should not be more than 20%. Keep in the mind, this is very important point. Once again, total reserve margin should not be more than 20%. Then second case or B point, annual energy generation 500 megawatt units, it is given by 6000 kilowatt hour per kilowatt. 200 or 210 megawatt, it is 5500 kilowatt hour per kilowatt. Units with less than 200 megawatt, that is 5000 kilowatt hour per kilowatt. In case of eastern and northeastern regions, a forced outage rate of 22% is assumed. Then C, availability from new units. The peaking capacity and annual energy generation capability of newly commissioned thermal and nuclear units would be taken as shown below. Peaking capability under this one, during first 3 months of commissioning, nil. Next 9 months 50%. After 1 year it is 100%. B, energy generation. First year it is expected 2500 kilowatt hour per kilowatt. Second year 4000 kilowatt hour per kilowatt. Third year 5000. Fourth year 6000, and so on. D, for hydro plants. Normal for deciding overall peaking capabilities of hydro units would be as discussed below. Rated capacity minus maintenance of 3% plus forced outage of 9.5% first plus auxiliary consumption of 0.5%. The peaking capacities and energy generation capabilities of hydro stations shall be determined taking different factors. Those factors are hydrological considerations requirement, hydrological conditions, requirement of water for irrigation. These two factors are to be considered in case of hydro power plants. Next one, scheduled maintenance. It is already well known that power system is also one of the industry. In any industry, maintenance will affect the performance and its output. Here also better management, better maintenance is very much essential to provide uninterrupted power supply and quality power supply. The maintenance schedule of generating units which influence the generation dispatch schedules shall be drawn up with a view ensuring practicable and equal availability of gross operating reserve margins. The maintenance schedule shall be taken into account of monthly variations in system peak load and hydro availability. In general, the main aim of the maintenance is to maximize the maintenance of thermal plants when higher quantity of water is available, that is high hydro is available. It is very simple. When high hydro is available, maintenance of thermal may be done. When the low level of water is available, hydro maintenance should be done. Getting the idea? Once again, when the high water is available, that means thermal may be given off. When the low water is available, hydro may be given off. This is the understanding, sir. The periods of scheduled maintenance in 1 year for hydro, thermal and nuclear units are as shown in below. Number 1, hydro units for in 1 year 30 days, that is maintenance period. Number 2, conventional thermal units up to 250 megawatt 45 days in 1 year, and 500 to 600 megawatt thermal units, so it is increased to 60 days per year. Similarly, for nuclear power plant of capacity 200 to 235 megawatt, it may be 45 days. 500 megawatt 60 days. For 1000 megawatts it may be increased up to 75 days. Hence the better maintenance increases the reliability. Improper maintenance reduces the reliability. Hence, thank you sir to one and all.